This is part 2 of lesson 6.5 covering the rhombus shape and the square shape of parallelograms and what qualifies as each of those. So here are some conditions or some theorems that you can use to help prove that a parallelogram is a rhombus. Rhombi is the plural form of rhombus, or a square. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So I have this little chart down here. I'm going to kind of fill it out with you. I'm going to start here and then kind of work backwards and go back to rectangles. So if diagonals of a parallelogram are perpendicular, here's diagonals. If they are perpendicular, it is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So if a diagonal cuts opposite angles in half, then it is a rhombus. Opposite angle bisectors, that's true. These are qualify as rhombi. If one pair of consecutive sides of a parallelogram are congruent, then it's a rhombus. So the side and the bottom, or the side and the top. If they are the same length, then we know it qualifies as a rhombus. So consecutive sides are congruent. And then finally, if a quadrilateral is both a rectangle and a rhombus, then it is a square. So it has to qualify for all these rhombi characteristics and everything that's a rectangle characteristic. If it qualifies for both, then it is a square. So we know that these are true for a parallelogram to be a square. What qualifies as a rectangle? Are the diagonals of a rectangle congruent? Yes, they are. And if that's true for a rectangle, we know it also has to be true for a square, because everything that qualifies as a rectangle also qualifies as a square. Okay, the diagonals of a rectangle are not perpendicular. If they are, then it qualifies as a rhombus. The diagonals are not angle bisectors, opposite angle bisectors in a rectangle. They are in a rhombus, but not in a rectangle, so we leave that open. All right angles. Are all four corners of a rectangle 90-degree angles? Yes, they are. And if that's true, then we know it has to be true for a square as well. And then in a rectangle, are consecutive sides always congruent? Do they have to be congruent for it to be a rectangle? No. In fact, usually in a rectangle, consecutive sides are not congruent. One thing I want you to keep in mind is that a square qualifies as a rectangle. It's a more specific type of rectangle. So all squares are also rectangles, but all rectangles are not squares, right? A specific type of rectangle that has all congruent sides is a square. But rectangles aren't all squares, right? All squares are rectangles, not all rectangles are squares. Same thing for a rhombi, for a rhombus. All squares are rhombi. They qualify as a rhombus, right? But not all rhombi qualify as squares, right? If they're tilted to the side, they don't have four right angles, so they don't qualify as a square. But all squares meet all the qualifications of a rhombi. I hope that kind of makes sense and doesn't confuse you. So we're going to use this little chart right here, this little cheat sheet, to fill out the 4 questions below. And it is tedious work because we are going to be using the, slope formula and the distance formula again. But to know what we're trying to use, we're going to go off of this picture. Okay, so for number 1 here, it says, given each set of vertices, determine whether parallelogram ABCD, this little tilted rectangle looking shape means parallelogram, ABCD is a rhombus, a rectangle, or a square. List all that apply and explain. So if our answer is square, we know it could also be a rectangle or a rhombus, possibly both, right? But we have to list all that apply. So first of all, number 1. I am going to kind of imagine, I'll sketch a little 4-sided shape here, A, B, C, D. I made it look like a rectangle, but it might not be. It might be a rhombus, it might be a square. I don't know yet. I'm just kind of giving myself a little shape to go off of. Okay, so is this a rectangle, a rhombus, or a square? Well, which category doesn't include all of them? Basically every category, right? It's one or the other. So here, 2 of these, a rectangle or a square, have congruent diagonals. A rhombus does not. So let's start there. Let's compare the length of the diagonals, and that's going to tell us if it's a rectangle or a rhombus. It can't be both. If it's a rectangle, it also qualifies as a square, right? So let's see. We're going to compare the two diagonals. To know what my two diagonals are, I'm going to look at my little shape I drew. Looks like AC is one diagonal and DB is the other diagonal. And I have to use the distance formula. So I'm going to start with AC. Distance of AC is x minus x squared. So I'm going to use 0 minus 4 squared. The printing didn't turn out real good here. Plus y minus y squared. 2 minus 2 squared. Then I'm going to simplify that. 0 minus 4 is negative 4. Negative 4 squared is 16. 2 minus 2 is 0. 0 squared is 0, so I don't add anything here. And when I simplify, I get 4. Okay, then I want to compare that to the other diagonal, BD or DB. So same thing, square root of x minus x, 2 minus 2 squared, plus y minus y, 4 minus 0 squared. 2 minus 2 is 0. 0 squared is 0, so I don't write anything. 4 minus 0 is 4. 4 squared is 16, and the square root of 16 is 4. So it looks like here the two diagonals are the same length. So we can go ahead and rule out rhombus, because a rhombus does not have diagonals that are the same length. So we know it's either going to be a rectangle or a square, potentially both, right? So I want to look at other, rectangle categories that, let's see. I want to look at another category. These match up. That is a square, but not a rectangle, right? If I compare these, they're both the same. So I don't know if one is a rectangle or a square. So far, they're both. Same thing here. If I compare both and they both turn out, I still don't know if one is just a rectangle or just a square. But if I pick a category that just qualifies for a square and it doesn't end up true, then I know it's just a rectangle. If it does end up true, then I know it's a square, right? So here, I'm going to pick consecutive sides are congruent. So I'm going to compare my two sides, two of the sides here. So like let's say AB and BC. I'm going to compare those two sides. They have to be the same length to be a square, right? If they're not the same length, then they are a rectangle. But if they're the same length, they are a square. So that's what I'm going to find next. The length of I just found the diagonal, so I have to do two more sets of distance formulas. The length of AB is x minus x, 0 minus 2 squared, plus y minus y, 2 minus 4 squared. 0 minus 2 is negative 2. Negative 2 squared is 4. 2 minus 4 is negative 2. Negative 2 squared is 4. And when I add those both together, I get square root of 8. Okay, so now I want to compare that to side BC. I know this is 8, but what about this side? If it's 8, then I know this is a square. If it's something other than 8, then I know it's a rectangle. See how that kind of works? All right, so for BC, x minus x, 2 minus 4 squared, plus y minus y, 4 minus 2 squared. 2 minus 4 is negative 2. Negative 2 squared is 4. 4 minus 2 is 2. 2 squared is 4. And I get square root of 8. So they are the same. Consecutive sides are the same. Therefore, since they are the same, the only thing that that's true for, we compared the diagonals and consecutive sides. The only category that has both of those checks marked is a square, right? Rectangle does not have this box checked off. Square does. So I know this shape is a square. So I'm going to write square down here. Okay, for number 2, I'm going to start off the same exact way. The only thing I have is the vertices. I want to figure out, is this shape a rectangle, a rhombus, or a square, right? If it's a rectangle, it could also be a square. If it's a rhombus, it could also be a square. We just have to see what boxes can get checked off, right? So here, for number 2, I'm going to start off by comparing the diagonals. So start with AC. Square root of x minus x squared. So negative 2 minus 3 squared. I know it's hard to see that. I already said that once. And then y minus y, 1 minus 1 squared. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. 1 minus 1 is 0. 0 squared is 0. So I don't put anything. And the square root of 25 is 5. Okay, so I want to compare AC to the other diagonal, BD. Distance formula again. X minus x, negative 1 minus 2 squared plus y minus y, 3 minus negative 1, 3 plus 1. Okay, negative 1 minus 2 is negative 3. Negative 3 squared is 9. 3 plus 1 is 4. 4 squared is 16. When I add 9 and 16, I get 25, and the square root of 25 is 5. So these are the same. The diagonals are the same. So again, I'm looking at either a rectangle or a square because they both have this box checked off, right? So then I want to see, are the consecutive sides congruent? If they are, then I know it's a square. If they are not, then I know it's a rectangle. I could have gone with another box too. I could have used slope formula to figure out if one side of my shape is perpendicular to the consecutive side. I could have done that. I could have figured out if, I can't figure out the angle bisectors because I have nothing when it gives me the vertices here on a coordinate plane. That doesn't measure an angle, right? So I can't test this out for any of them, but I can test out these other categories. So this one's kind of out of the loop, this whole. We'll kind of shade this in. We can't really use that one for now. It's still true. We just have no way of measuring the angles. So I can measure this, 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 or this. I'm picking this. I've already said this is true. Going here. So consecutive sides are congruent. I'm going to measure the length of AB and the length of BC, just like I did here in number 1. Do a different color. So the length of AB, again, distance formula, x minus x, negative 2 minus negative 1 squared. Y minus y, 1 minus 3 squared. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 minus 3 is negative 2. Negative 2 squared is 4. So I get square root of 5. Okay, I want to compare that to the side next to it. I've got AB. That's the length of AB. I want to compare it to this next side to see if they're the same. If they're the same, then it's a square, right? So here, BC. Excuse me, my allergies are bad again. And then let's see, negative 1 minus 3 squared plus 3 minus 1, I guess, squared. Negative 1 minus 3 is negative 4. Negative 4 squared is 16. 3 minus 1 is 2. 2 squared is 4. Uh-oh. And I get square root of 20. So these are not the same. So the length of consecutive sides of my shape, whatever that shape is, are not the same. So it cannot be a square. The only other thing I checked off or tested out was this column, and they both qualified. Now I checked out this column, and this bottom guy does not qualify. This is not true. The sides are not congruent, this consecutive sides. So it has to be a rectangle. Okay, let's do the next one. I know this is super tedious, but good to have practice, right? I'm gonna use green. I'm gonna start off measuring my diagonals again, AC and BD. If they end up not being consecutive, then right off the bat, I know it's a rhombus, right? Number 3, AC square root of x minus x, negative 2 minus 2 squared plus negative 1 minus negative 1 squared. Negative 2 minus 2 is negative 4. Negative 4 squared is 16. Negative 1 plus 1 is 0. So I add nothing there. So I get 16, which equals 4. The length of AC is 4. Now I got to find the length of the other diagonal, BD. 0 minus 0 is squared, is just 0. And that's not going to turn out to be anything. And then 2 minus negative 4. Remember, 2 minus negative 4 turns into 2 plus 4. 2 plus 4 is 6. 6 squared is 36. So I get square root of 36, which is 6. Oh, man, look at that. They're not congruent, right? So for diagonals, if they are congruent, it's either going to be a rectangle or a square. If they're not congruent, it's going to be a rhombus. So these two are checked off. They don't work. This one is the only one that proves to be true. the diagonals are not congruent. This is a rhombus. I don't have to prove anything else. All right, and then lastly, number 4, same thing. I'm going to compare diagonals first. AC, x minus x, negative 3 minus 5 squared plus 0 minus negative 1 squared. If you see me writing plus, when I say minus and negative, when you have a double minus sign, you make a plus sign, right? That's why I'm writing plus. All right, negative 3 minus 5 is negative 8. Negative 8 squared is 64. 0 plus 1 is 1. 1 squared is 1. So I get square root of 65. And I can't take the square root of 65, so I'm just going to leave it. Then I'm going to compare it to the other diagonal. Square root of negative 1, this is BD, negative 1 minus 3 squared plus y minus y, 3 minus negative 4. Negative 1 minus 3 is negative 4. Negative 4 squared is 16. 3 plus 4 is 7. 7 squared is 49. 16 and 49 is what? 16 and 50 would be 66. So it's 1 less than that since it's 65. Okay, so they're the same. The diagonals are the same. So I know if the diagonals are congruent, I'm looking at either a rectangle or a square. So then I want to go over here and see what this column says. If it proves to be true, if the consecutive sides are congruent, I know I'm looking at a square. If the consecutive sides are not congruent, then I know I'm looking at a rectangle. All right, so I'm going to compare, again, just like I did before, I'm going to compare the top and the side. So AB and BC. I'm going to find the length. If they're the same, then it's a square. If they're not the same, then it's a rectangle. AB, square root of x minus x squared, negative 3 minus negative 1 squared plus 0 minus 3. Negative 3 plus 1 is negative 2. Negative 2 squared is 4 plus negative 3 squared is 9. So that's the square root of 13. So one side has a length of the square root of 13. The next side, BC, negative 1 minus 5 squared plus 3 minus negative 1 squared. Negative 1 minus 5 is negative 6. Negative 6 squared is 36 plus 3 plus 1 is 4. 4 squared is 16. That is way more than 13, right? I can tell right off the bat. 36 and 16 is 46, 52. Okay, so these are not the same. Consecutive sides are not congruent, so therefore this is a rectangle. All right, so we got for number 1, we got it as a square. Number 2, we got a rectangle. Number 3, we got a rhombus. And number 4, we got a rectangle. Next, we're going to do, and we're almost done with this video, we're going to complete a proof together. All right, so this is our proof. Write a 2-column proof given that parallelogram RSTU, meaning there's a 4-sided shape, it's quadrilateral, it's RSTU, it is a parallelogram, and segment RS is congruent to segment ST. There is a picture. It's a really, really crappy picture. You can't see it very well. Pardon my French. So I'll try and draw over it. And this is an R, this is an S, this is a T, and this is a U. Okay, so this is what the picture looks like. So this is saying the entire thing's a parallelogram. So opposite sides are parallel, right? And then RS is congruent to ST. This guy is congruent to this guy. All right, so we have to write a proof proving that not only is this a parallelogram, it's also a rhombus. So I'm going to write a 2-column proof. Statements, reasons. It's going to be a lot shorter than you think, or maybe you think it's going to be short. And in that case, you are right. Okay, step 1 is always the given. So first, RSTU is a parallelogram, and instead of writing out the word parallelogram, because I'm lazy and I don't want to, we're going to draw a little parallelogram. So you can just read that as the word parallelogram. RSTU is parallelogram. And then RS is congruent to ST. And that's given. Okay, so step 2. What do I need to be able to prove that this is a rhombus? Well, on that last paper we just filled out together, here, it gave us some theorems, right? And the theorems don't really have names. They're just kind of facts that you can use in a proof to prove a shape is a rhombus or a square. Okay, so if we'll look at this one right here, if one pair of consecutive sides of a parallelogram are congruent, the parallelogram is a rhombus. One pair of consecutive sides, right? Well, over here, aren't these consecutive sides? Isn't this side and this side consecutive? Aren't they right next to each other? Yes. So if these are the same, and in a parallelogram, opposite sides are congruent, so this guy has to be the same as this guy, and this side has to be the same as this guy, just definition of parallelogram. Then if I know these are the same length, I know these are the same length, which means all four sides are the same length, which means this is a rhombus. Right? Now we could go further and prove more and possibly prove that it's also a square, but we don't need to go that far. Once we prove it's a rhombus, that's all we had to do. So all we're going to do here in step 2 is say RSTU is a rhombus. And why am I allowed to say that? What's the rule that says I can just say it's a rhombus? Because I'll repeat the thing from the front side of this. If one pair of consecutive sides of a parallelogram, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Then the parallelogram is a rhombus. That's a condition, right? If that's true, we know our shape is a rhombus. So this proof is a 2-column proof, but it was literally 2 steps. They gave us everything we needed. We just had to organize it, right? So easy peasy. Don't make things out harder than they have to be. And use in these notes that I gave you, I mean, it helps if you print them out or at least write it down. But these things we went over, and I did include this file so you can look at it, print it out if you want, or copy them down. These 4 statements, actually the first 3 are good conditions that prove something's a rhombus. The 4th one just says, if a quadrilateral is a rectangle and a rhombus, if it meets all these criteria, right, then it's a square. Okay? Let me know if you have questions.